Welcome to another unit of the ISM Statistics 1 exercise set. This time with an exercise on rank correlation and Spearman's rank correlation coefficient. Let's take a look at the exercise. A hotel asks its guests to evaluate the service quality of the reception and of room service after their stay. The scale to be used is as follows. On the first day, 5 guests have given their feedback resulting in the table below. Use a suitable bivariate measure to quantify the strength of the relation between the two parts of the evaluation. Well, we directly see the smileys, they can be ordered as in the scale from very good to very bad, but it's pretty hard to actually get an idea about the distance between any two smileys. So we have an ordinally scaled variable, but not intervally scaled, meaning we need to use Spearman's rank correlation coefficient as a bivariate measure of association. Okay, let's jump right into this. So first off, we take our original table and using this assignment so that rank 1 is the best and rank 5 is the worst result. So starting from this table, we see that for the reception, which would be here rank of X, the room service rank of Y, starting with the reception, the first guest gives us the second best, so this is rank 2. Second guest gives it the best, so this is rank 1. And the worst, middle one, the second to last. Similarly for the room service, we have the third one, the second best, the worst, the best, and the second worst. Those numbers we can then use to actually calculate the statistic. For this, we have two possibilities. First alternative, we just apply the Pearson correlation coefficient to our rank data. In this case, we take the table, add one additional row where we just square the ranks of X. So we go 2 to the power of 2, 1 to the power of 2, and so forth for the other ones. And then we do the same thing for Y. We just square all the ranks of Y. Finally, in the last row we have to add, we multiply the ranks of X and the ranks of Y. So we have 6, 3, 25, 3, and 16. However, we're not interested in those raw values, we're interested in the averages. So as a first step, we just sum up all the values. And then we divide them by 5, as we have 5 observations, 5 guests. So we get, and another in the final column, our averages. So we have for reception and room service both an average of 3. We have for the squared variables both an average of 11, and for the last one an average of 10.4. Those are actually the numbers we need because, as we can see here, the rank correlation coefficient in this context, as it is based on Pearson's correlation coefficient, looks as follows. So above the fraction line we have 10.4, that's the average of rank of X times rank of Y, minus rank of X, the average, minus the average of rank of Y. So 3 times 3. Below the fraction line, here we have 2 roots. However, if we take a look at our table again, we see that both roots are actually the same, because the average of the squared rank of X equals the average of the squared rank of Y, and the rank of X, the average rank of X and the average rank of Y also are the same values. So in the first one, we have below the first root 11 minus 3 to the power of 2, so 11 minus 9. And as I said, both roots are equal, so we get 2 times the same result. If we insert the values, looks like this, and we get as final result 0.7, which is actually pretty high and describes a positive correlation. Positive means if a guest gives a good evaluation of one part of the hotel, he usually also gives a good evaluation of the second part, and if he gives a bad review in one part, usually also gives a bad one in another. Also, as the rank correlation coefficient takes values between -1 and +1, 0.7 is actually a pretty high value, so this is a pretty strong correlation between both evaluations. And as I said, there are 2 alternatives. we take a look at the second alternative, we can only use this alternative if each rank is assigned only once. Taking a look again at our values, we see each rank from 1 to 5 is assigned only once. And only then this is possible. The first alternative, this can be used in any case. This one, only if every rank is seen only once. What are we going to do in this case? We add only one additional row. There we calculate the difference between the two ranks and square the difference. So here we go, 2 minus 3 to the power of 2 is 1, 1 minus 2 squared, 5 minus 5 squared, 3 minus 1 squared, and 4 minus 4 squared. Again, we sum them up. Here we don't need the averages. This is actually all we need. In particular, we only need the last one, we only need the 6, because here the rank correlation coefficient becomes much easier in the way of the following formula. So here we go, 1 minus 6 times 6, this is the whole sum, divided by n is 5, times, in parentheses, 25 minus 1. So we insert this and we get as a final result, unsurprisingly, again the 0.7 as we got with alternative 1. So we saw in the case that each rank is assigned only once, both approaches give us the same result. If we were to have assigned a rank more than once, only the result from alternative 1 would actually make sense and be the correct one. The second one might be slightly too relatively significantly biased. So only use the last one once more if each rank is assigned only once. Well, and then this concludes this exercise. So I hope you enjoyed listening and learned something from this. And see you next time. Goodbye.